time to go over pages 8 and 9 in the packet. So for this first question, we are first asked to describe the motion. Okay, so we have forward, and if we look at the slope of the 3 different lines within this graph, this slope is actually the steepest. So I'm going to say forward quickly, then standing still, then moving backward at a medium pace. Okay, because this, again, this slope here in the middle is like the middle slope. Okay, backward at a medium pace. Then forward slowly, because again, this final one is the, I can change the color of this. This final one is the actual slowest. Okay, what is the object's starting position? For starting position, we just look at this right here. So we look at the y-intercept. So our y-intercept, or x naught, I'm not sure how to do the little, just like that. X naught is equal to 0 meters. Okay, and I get meters from my unit up here. Okay, label each section with the graph's velocity. Okay, so we want to, for velocity, we do rise over run, and I'm actually going to label these sections C, D, and then I'm just going to put the velocities over here. So for A, we have a rise of 60 meters over a run of 10 seconds. So that means that we have a velocity of 6 meters per second. For B, we have just 0, because do we see how it's a flat line? So that means we have a rise of 0 meters, a run of 5 seconds. So we get 0 meters per second. For C, excuse me, we have a rise. We go from 60 all the way down to -40. Okay, so if we count, that is -100 meters of a rise. And then we go from 15, so 5, 10, 15, 20, 25, so a run of 25 seconds. So we end up with -4 meters per second. And then for D, we have a rise of +40, because we go from -40 to back to the origin. So 40 meters divided by, and then for our run, we have 5, 10, 15. Okay, so 40 divided by 15, we end up with 2.66. Next one, so I'm looking at this second graph. I'm asked to describe the motion from 12 to 20 seconds. And then I'm also in this third part asked to determine the velocity. So all of these from 12 seconds is right here, okay, and then 20 seconds is here. So I just want to differentiate what the velocities are before I am describing all this motion. Okay, so I'm going to go through and describe the velocities first. I'm going to go ahead and skip over all of the flat lines, okay, because we know that all the flat lines are just 0 meters per second. Okay, all the flat lines are. Okay, so I'm going to start over here with this segment from 2 to 5 seconds. Okay, so for 2 to 5 seconds, I have a rise of -3. So I go down 1, 2, 3, -3, and then I go also over 3. So 3 meters divided by, -3 meters divided by 3 seconds, and we end up getting -1 meters per second. For this segment from 5 seconds to 7 seconds, we have a rise of +5. Okay, so just if we count these boxes, +5, and then we have a run of +2. So 5 divided by 2, we end up getting 2.5 meters per second. Okay. Then, of course, we have 0 meters per second, and then we have this segment from 12 seconds to 14 seconds. Okay, and from 12 seconds to 14 seconds, we have a rise of -8 meters, and that is 2 seconds long. So we have -4 meters per second during that segment. Then we have this segment from 14 seconds down here to 16 seconds here. For that segment, we have a rise of 4 and a run of 2. So we end up with 2 meters per second. Then, of course, for this flat segment, again, we have 0 meters per second. And then from 18 to 19 seconds, we have a rise of +2, a run of 1. So we end up just getting 2 meters per second. And this is for this little segment here. Okay. Okay, so let's go back up and describe the velocity, or describe the motion from 12 to 20 seconds. So we are moving backward very quickly, then forward slower, then we stand still. Okay, and standing still is just this little flat portion here. Then continue forward, I'm just going to say at a normal pace for this one, so that then we can kind of describe that back. So then continue forward at a normal pace, then stand still. Okay, so while reading through this, it's very clear that I have 3 different velocities that I am moving. So I have the -4 meters per second, which is very quickly, and then I have the 2 meters per second and 2 meters per second, which is my normal pace. Okay, then we're asked what is our starting position. So for that, we look at what our y-intercept is. So x naught is just equal to 0 meters. And we've already done the labeling. Okay, so describe this motion. So just kind of looking at this, I think I can differentiate between the different motions without calculating velocities first. Okay, so I'm just going to do that quickly. So standing still, then moving forward, then standing still, then moving backward quickly, then standing still. Okay, so that brings me up to right here. Then moving backwards slowly, then standing still. What is our starting position? Our x naught is equal to 0 meters. Again, I'm just looking at my y-intercept for that. And it asks us to label velocity. Okay, so remember, each flat section is just 0 meters per second. Oops. Okay, so then we just have 3 velocities to calculate. So if I'm looking at this graph, I notice that my y-axis is counting by 1s and my x-axis is counting by 2s. So I need to make sure that I'm counting very carefully as I'm actually figuring out what my rise over run is. So for this first one, my rise goes from 0 to 8, so that's just 8 meters. My run, though, goes from 3, okay, because it's right between 2 and 4, to 11, which is right between 10 and 12. So my run is 8 seconds. So my velocity here is 1 meter per second. Okay, now we're going to do this downward segment here. My rise is -6 because I go from +8 down to 2. And my run is 2. I'm going from 16 to 18. So I'm moving at -3 meters per second. This is our fastest movement for this graph. Then the third slope I need to calculate is over here. So my third slope, I go from, my rise is from 2 to 0. So my rise is -2 meters. My run is 20 to 25. So my run is 5 seconds. And we end up getting -0.4 meters per second. Okay, moving down to this next portion. Okay, so we're asked to describe the motion again. So we are moving forward slowly, then stand still, then forward quickly, and looking at these two, I'm not sure which one I'm moving fastest in, so I'm just going to pause for a second and calculate these velocities just to see which one I'm moving faster in. I'm noticing that there's no label for my x-axis, so I'm just going to say that my x-axis, each of these markings is 1. Okay, so 1, 2, 3, 4, 5. So for example, this one would be 5 seconds. Oops. Okay. I'm just going to say that I'm counting by 1s here. On my y-axis, I'm counting by 5s. Okay. So I'm just going to figure out number 3 and number 4 really quickly, and then I'll go back and do the others. So number 3, we have a rise of 10. Because we're going from 10 here, I'm sorry, yeah, we're going from 10 to 20, and then we have a run of 1, 2. Okay, so for number 3, it's 10 divided by 2, so we have 5 meters per second. Okay, that's for number 3. For number 4, we have a rise of negative 30 because we're going from positive 20 here to negative 10 here. So negative 30 divided by 6. 1, 2, 3, 4. Oops, it's actually 5. 1, 2, 3, 4, 5. Divided by 5. And we end up getting negative 6 meters per second. So we are going a little bit quicker in 4 than we are in 3. So I need to make sure that I am detailing that in my motion. So then forward quickly, then backward quicker, even quicker, then stand still. Okay. So our starting position, our x0, and this is just our y-intercept over here, is just 0 meters. Okay, and then if I'm looking at number 1, for 1, I have a rise from 0 to 10, so I have a rise of 10 meters. I have a run of 5, so I'm moving 2 meters per second during this portion. Okay, during 2, of course, I'm just moving 0 meters per second. And the same for number 5. Trying to position these so they're a little bit more obvious what's what. Okay. Okay, and then looking at this, again, I have 2 velocities that look really similar, so I want to figure out what those velocities are before I describe my motion, just so that I know how to compare those. Okay, so again, any flat line, we are always moving 0 meters per second. So those are easy to fill in. Then I actually have to do some calculations for all of these sloped lines. So for this first slope line, I have a rise from negative 2 to 0. So I have a rise of positive 2. And then I'm going from 2 to 5. So a run of 3. So my velocity here is 0.67 meters per second. I'm always rounding to the 100th here. Okay. Then this next sloped line, I go from 0 to 3, so I have a rise of 3 divided by 1. So I have a velocity of 3 meters per second. For this next sloped line, I go from positive 3 to negative 3. So I have a rise of negative 6 meters. And I have a run of 2 seconds. So I end up with negative 3 meters per second. Okay, so let's describe the motion. So I'm standing still, then moving forward slowly, then standing still, then moving forward quickly, then standing still, then moving backward quickly. Okay, and during this segment here and this segment here, I am moving at the exact same speed. I just have different direction. My starting position is, so my x0 is equal to negative 2 meters. Again, for starting position, we are just looking at our y-intercept. Okay, so now we're going to say that this is a velocity time graph. And this becomes a little bit tricky. Okay, we're going to talk about this a little bit later in the week. but just to get a little bit of a head start on it. So I'm going to label each section. D, E, and then I'm going to break this last section, which we thought of in the position time graph as one whole section. I'm going to break it into 2 sections now. And again, I want us to think about what our y-axis means and how that shifts what this graph says. So where is the object moving the fastest? Okay, so if we have a flat line on a position time graph, that means that we have a constant position, right? That's what we were saying up here. Down here at this first flat line, we have a constant position because our y-axis says position, right? So here, if we have a flat line, that means that we have a constant velocity. So where is our velocity fastest? E. Our velocity at E is positive 3 meters per second because that's the constant, right? You could say that at the very tip of G down here, you're also moving, you're moving negative 3 meters per second. But I think that's kind of splitting hairs here, okay? Okay, so when is the object moving backward? So backward equals negative velocity. So where do we have negative velocity? We have negative velocity anywhere underneath the x-axis, just like we have negative position in a position time graph anywhere underneath the x-axis. So here we have negative velocity in A, B, and in G. Okay, so when is the object standing still? So standing still equals velocity of 0 meters per second. And again, our y-axis is telling us velocity. So 0 meters per second is right here, where our x-axis and y-axis intersect. So where are we on our x-axis? Here, at C. Okay, again, we're going to talk more about this later in the week. Okay, so back to a position time graph here. Okay, so what are each of these doing? What is A doing? A is standing in one position one positive position, okay? What is B doing? Okay, so B is right here. B starts behind 0 meters and moves forward. What is C doing? C starts ahead of 0 meters. Okay, so starts in a positive position and moves backward. What is D doing? D starts behind 0 meters, moves backward, and then stands still. And then what is different about A and E? So A is up here and E is down here. So both are standing still, meaning they have constant position, okay? But A is in a positive, whoops, if I can spell today. Oh my goodness. A is in a positive location and E is in a negative position.